Hey everybody, I'm going to go over the stations review for the test, for the Unit 2 test. And let's go over this Station 1 matching here. So the way that I'm going to do it is I'm going to go down through this column and match it, and then I'm going to go through this column. That way I know that I get all this stuff. Okay, so the four-element theory here, that was Aristotle, so I'm going to put an A there. Okay, the neutron, the discovery of the neutron was Chadwick, so that's B. The mass of an electron was Millikan, C. The nucleus was Rutherford. That electrons are negative, that's Thomson. Atomos, that was Democritus, so that's F. Modernized chemistry, that's Boyle. And the atomic theory was Dalton, H. And then the gold foil experiment was Rutherford, so I'm going to put a 1 there. Famous philosophy, that was Aristotle. Okay. Gas laws, okay. I don't think that you would know this one, so if you don't know this one off the top of your head, that's okay, but that's going to be Boyle. The oil drop experiment is Millikan. The cathode ray tube is Thomson, J.J. Thomson. Okay. Less famous philosophy was Democritus. He was the less famous philosopher. Experiments that support atomic theory discovery. The atomic theory was Dalton, so that's going to be 7. And then the famous beryllium experiment by Chadwick was 8. Okay. So, now let's look at the bottom here. Okay. And so we have, I'll do the same thing. I want to read these and match them up with the name. It's easier to take the phrase and match them with a singular name than it is do it the other way. Okay, so the father of the periodic table is Mendeleev. Used octets to organize the elements. So the octets guy was Newlands. Okay. Had an atomic model where the electrons orbit the nucleus like planets orbiting the sun. That's Bohr. That's the Bohr model. He put elements using the atomic number. That's Moseley. Okay. And then developed the electron cloud model. That's Schrodinger. And then triads is Dobereiner. Okay. Okay, so that's Station 1. Okay, Station 2. Okay, so this is vocabulary of the periodic table. Okay, and again, I'll go back through and I'll match here and find the letter over here. So the name of group 18 is the noble gases. So that's A. Group 1, 2, and 13 through 18, that's the main group, so that's B. Okay, the dark line that separates the metals from the nonmetals, and you can see on here I kind of have a blank periodic table. Okay, we'll do that in a second. But the dark line is called the stair step. Okay, groups 3 through 12, that's in here, so that's going to be the transition metals. Okay. And then the name of group 17. Group 17 is the halogens. The name of the columns, so this is the names. Those are families, so that's going to be F. And then the number of the columns on the periodic table, those are group numbers. Okay. The name of group 1 is the alkali metals. Okay. Alkali has one word. It's group 1. And then the rows going across the periodic table, that's the period, and the name of group 2, alkaline earth, has 2, so that's going to be there. Okay. And then it says label the periodic table with the 10 words above, include metals, nonmetals, and metalloids. So here's what I'm going to do. I'm going to go here. These are nonmetals. These are metals here, all of these, and the metalloids are these here. Okay, so I have that listed. Okay, so this is the stair step. Okay, stair step. The main group, let's see, is this and this here. So this is the main group. It's hard to do that one, but it's fine. Okay, these guys here are the transition metals. Okay, the noble gases are here. Noble gases. Okay, the halogens are right next door. Okay, the alkaline earth metals, alkaline earth is here. The alkali metals are right next door. Okay, and then a family. Okay, family. Woo. Okay, groups. Okay, families and groups. And then the last one is period. Okay, no cap. Okay, is that. Okay, so here we go. Station 3. Okay, fill in the information about the subatomic particle. This is straight from the notes, and I wanted you to know this. Okay, so the symbol for a proton is P, the neutron is N, and the electron is E negative. So this is the nucleus. Okay, the nucleus, and this is the electron cloud. Okay. The relative mass of a proton is 1. Compared to a neutron, they're the same, and an electron weighs 0. This is the smallest particle. Okay, it doesn't have any mass. Relative charge, proton is plus, a neutron is 0, and an electron is minus. Okay. Now, nuclide symbol. What element is represented by the nuclide symbol above? This is chlorine. Okay. What is the atomic number of the element? That's this. So that's going to be 17. What's the mass number? 35. What is the charge? 1. So all of these are determined just by reading the symbol. Okay. Now we're going to have to do some math here for these 3. So this is going to be 17. Okay. How many neutrons? When we do neutrons, we subtract. So that's going to be 18. And when we determine the number of electrons, we compare. So there's 1 more electron than there is protons, so that means there's going to be 18 electrons. Okay, and then lastly, chart problem here. Okay, for boron, that's atomic number 5, so it has 5 protons. The charge is 3 minus, so that means there's 8 electrons. The mass number now is these 2 added together for 11. Okay, atomic number 11 is Na. The number of protons is 11. Neutrons now, remember these 2 columns these 2 columns add up to give you 24, so this must be 13. The number of electrons you compare to get the charge, so this has to be 10 because there's 1 more proton than there are electrons. Okay. So, for element number 31, this is Ga. Remember these two are the same. Okay, and then for the charge, you compare protons to electrons. There's 3 more protons, so it's 3 plus, and then the mass number is these 2 columns added up, which is 68. Okay, and then element number 39 is yttrium, and these 2 columns are the same. Okay, and so remember protons plus neutrons gives you the mass number, so this has to be 50. Okay, and then to get the charge, you compare protons to electrons, and so that's going to be 3 plus. Okay, so that's station 3. Okay, station 4, you have to do some math. Okay, so I can guarantee you're going to see one of these on the test. Okay, and so how many isotopes are shown? This is 2. You have 2 peaks, so you have 2 isotopes. What is the mass number of the most abundant one? Okay, well, this is the mass number down at the bottom. Okay, so 69 is the mass number, and it says calculate the atomic mass of the element. So to do that, okay, you're going to do 69 times, let's see, 60.11, but that's the percentage, so you move the decimal over. Okay, and then you're going to do 71 times its percentage, but move the decimal over 2 spots. So 71 times 0.3989. Okay, and then you get an answer. So this is 41.4759, and this is 28.3219. And then we add those together. We get 69.7978. Okay, and that's what we would expect. It's between 69 and 71, but it's closer to 69. So that makes sense. Then we use the periodic table. Periodic table is, we look for the mass of 69 point, what we need here, and it's going to be gallium. Okay, and now for hydrogen, I asked this question because you have to set this problem up, but you have to make sure you move the decimal point always 2 spots. Remember, 2 spots, dua lipa. So we're going to go for hydrogen 1, it's going to be 1 times 99, so we move it over 0.99. And then for hydrogen 2, that's 2 times, move it over 2 spots, so it's 008. And then for hydrogen 3, it's 3 times 0.002. Okay, now we do this math. We get 0.099, we get 0.016, and we get 0.006. And we add that up, we get 2, let's see, let's see, 2 carrier 1, 1. I'm trying to add this in my head. Okay, good. So you get 1.02, 1.012 AMUs, and that lines up with the periodic table. And then it says, what is an isotope? So this is atom with different number of neutrons. Okay, so as long as you have different number of neutrons, that's the key there. Okay, so station 5 now. Whew. Okay, electron configuration. So it's like do the orbital box notation, and it says valence shell, valence electrons, kernel electrons. Okay, so chlorine has 17 electrons, potassium has 19. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. And then the valence shell is 3, valence electrons is 7, and the kernel electrons for this one is 10. Okay. Now potassium, only 2 electrons away. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now the valence shell is 4. The valence electrons is 1, and the kernel electrons is 18. Okay. Oh, and that answer goes here. Okay. So valence shell for chlorine is 3, valence electrons is 7 for For potassium, it's 4 and 1. Okay. So now we're going to write the electron configuration for these. So magnesium has 12 electrons, so it's going to be 1s2, 2s2, 2p6, 3s2. Or, if you wanted to, you could do Ne3s2. And the valence electrons is 2, the kernel electrons is 10, and the valence shell is 3. Okay. Calcium has 20 electrons, so we're going to go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Or we can do argon, 4s2. Okay, so the valence electrons is still 2, kernel electrons is 18, and the valence shell here is 4. Okay, sulfur has 16 electrons, so we're going to go 1s2, 2s2, 2p6, 3s2, 3p4. Or if we want to, we can go neon, 3s2, 3p4. Valence electrons is 6, kernel is 10, valence shell is 3. Now for argon, argon has 18, so we'll go 1s2, 2s2, 2p6, 3s2, 3p6. Or, now for this one, we cannot go argon like that. We can't do that. Okay, so we have to go back to the previous noble gas, which is neon, and then we go 3s2, 3p6. So valence electrons here is 8, kernel electrons is 10, valence shell is 3. Okay, and then last but certainly not least, this is just like the homework you did, and it says A, we pick A for the one in column 1, we pick B for the one in column 2, and then C if it's both, and D if it's neither. Okay, so this is straight from the worksheet. So N versus O, we want the larger one, and so we need to use the periodic table, and so that's going to be N. So that'll be A. Okay, the smaller one. So the smaller one is going to be N again. Okay, 2 valence electrons. Okay, that's going to be both of these. Okay, Li and F, which one has a lower ionization energy? So that's going to be the one that is the bigger one. So that's going to be lithium. Larger atomic radius. So that's going to be lithium again. Okay, smaller ionization energy. That's going to be the bigger atom, which is going to be chlorine. Okay, has the smaller electronegativity. So that's going to be the one that's the larger atom, which is going to be sulfur. So that answer is going to be B. 3 valence electrons. So the one that's in group 13 is aluminum. So that's A. Okay, so keep going. It's a noble gas here. So Ne is the noble gas. So that's going to be A. Mg and O, 6 valence electrons. O is in group 16. Okay, this is in group 2, so this is 2 valence electrons. Higher ionization energy, so we want the one that is smaller in size. So that's going to be bromine. Okay, so that's going to be B. And then higher ionization energy, again, we want the one that's smaller, so that's going to be F. Ne versus Ar, which one is smaller? It's going to be the one closer to the top of the periodic table. So that's Ne. Lower ionization energy is going to be one that's bigger. So bigger is beryllium. Smaller electronegativity. So that's going to be the larger radius. So the larger radius is strontium. And then increases going down a group. That's going to be radius. Again, unreactive, noble gases. And then has a valence shell of 4. And that's period 4. Look, I made the update there. So that's going to be A as well. Okay, so there it is. That's the answer key for the station's review activity.